So may I start my session today, right now? Is okay? Okay, so ladies and gentlemen, and so we will start the session named Disaster Management and Early Warning Sessions. And so my name is Naohiko Kotake, professor of Keio University, and so one of the committee member of the Multi-GNSS Asia. And so thank you very much for joining these sessions. And so we started this session 1:15, and so this session will be held in 1 hour. And so this is the agenda of these sessions. And so right now, so opening remarks and the introductions. And after that, so in this session, we have 4 presenters from United Nations and University of Indonesia and NTT Data, Japanese company. And so each presenter has 10 minutes presentations. And after that, we have a Q&A and discussions about the disaster management and the early warning system related to the GNSS. And so very short closing remarks. Okay. And again, so the we have our 4 presenters. And so would you kind to come this first presenter, second and third presenter. Second presenter online. And first presenter is Dr. Hamid Mehmood from UNSCAP. And second presenter is Dr. Sumi Hon, UNSCAP online. And third presenter is Dr. Lin Yora, University of Indonesia. And final presenter is Mr. Naoki Iso and Hitomi Westrin. Hamid, so would you move here? Yeah, because 3 more people said, yeah, it's okay. Yes, perfect. Okay, and so this is the address of the Zoom. And so currently more than 15 people join online. And of course, online people can ask the questions. Okay, so let's start the presentations from Hamid Mehmood, UNSCAP. And so do you want to use your computers? And so you can share a slide on Zoom. Yeah, thank you.
Thank you, Nahiko-san.
Yeah.
Thank you, Nahiko-san. Just to confirm, you can see my screen, right? Okay, perfect. Thank you. So, good afternoon, everyone. Welcome back to this session after the lunch break. So, I'll just introduce myself. My name is Hamid Mehmood. I'm the Economic Affairs Officer at UNSCAP. UNSCAP is the Economic and Social Commission that's based in Bangkok. And then inside that commission, there's a space application section. So I work at the space application section. Just an overview of how the space application section work. We have a plan of action. It's a 12-year plan of action. We're in the phase 2 of that plan of action. That plan of action has been developed by the member states in Asia and Pacific, and then they gave us the agenda or the mandate on to carry on different space-related activities in the region. Today what I'll do is that I will share the AI-related applications that we are developing at the space application section. The 3 initiatives are the SAT-GPT, there's an online course on how to use AI for geospatial data analysis, and the SDG monitoring in Asian Pacific using AI. So most of you would have used the LLMs. These are the large language models in your daily life. You are using it to write emails, technical reports. You send a question, you write a prompt, and then the LLM gives you a response. By LLMs, a more common name would be ChatGPT, or the Google has its own product. The new Samsung phone has its own product built into the phone. So at some point, you are impacted by LLM, and it has changed how you work. But coming from a remote sensing person who uses the satellite data, How does it impact you? So that was the question that we asked at space application section, that the field is evolving. People have started using LLM. How can we use the LLMs in our daily work? So there were two options. The first option was that we take the LLM, we train it on petabytes of satellite data, and then you can query that data based on the patterns available, and it can give you answer. For example, you can ask an LLM trained on satellite data, tell me about the floods that happen in Thailand or in Japan or in Vietnam or any country. And then it will process that petabytes of data and then give that information to you. But the problem with this option was that it was very resource intensive. You need a lot of computation power, you need a lot of satellite imagery, you need a lot of monetary amount or monetary resources to actually run this thing. And then it had a very big black box, because all the algorithms that you were developing, they were not open to the general public. And then you have the ethical issues, you have the participatory modeling issues, which we did not want it to engage. And the other thing we found out that is still in the research phase. There's still a lot of things that need to be fixed in this model. The other thing that we figured out is that what ChatGPT or any LLM is good at is programming, is coding. So you ask ChatGPT to write a particular code to solve a particular problem, and it will do it for you. And when we go for capacity development exercises in Asian Pacific, this is one of the bottlenecks that we face, especially in Asian Pacific, that people struggle with programming. They can define the problem, but they don't know how to write the code to solve that problem. And this is where we started developing this application, where what you can do is that you can ask ChatGPT to write the code for you. Then we send that code to Google Earth Engine, we execute that code, and then we show the output to the end user. So we developed it, we called it SatGPT, and then we developed a web app or a layer on top of it. So this is what it looks like. There's a prompt. You go just like ChatGPT, you write something in there, like tell me about the floods in Bangkok. It will ask you where do you want to map those floods. You click on the location, it executes the code on Google Earth Engine, and then you see the results. I will demo this to you after this presentation, and then this link is available to you. It's a general public link, and you can use it as much as you like. So this is something that we have done. During the process of developing this SatGPT, another thing that happened was that there was a lot of learning at our end on how to do very focused prompt engineering, that you just cannot ask ChatGPT to map a flood in Bangkok. You need to do a lot of prompt engineering, like the query would be, I am working as an urban planner, map the 2010 flood in Bangkok using Landsat data or Sentinel-2 data, whichever data you want to use. And that led to us following a particular framework of prompt engineering. And we realized that we need to share that knowledge that we have gained with the general public. And that is where we developed this online course in collaboration with the United Nations University. This is available on their platform. It's called Water Learning Center. You can go there using this QR code. You can enroll in this course. This is a free course. It's a self-learning course, self-paced course. It takes you about 10 hours to complete this course. At the end of the course, you get a certificate. We launched this course in December last year. I think 18 December 2023. And within 1 month, we got around 2,000 participants who enrolled in this course. The completion rate is around 20%, which is industry standard. But then again, it not only helps you to improve your prompt engineering skills for geospatial data, but also how you use ChatGPT for your daily life or for your work-related stuff. That's the feedback that we are getting from participants, that even if they're writing technical reports, the prompt engineering is really helping them. The last initiative that I would like to share with you is how we are using not ChatGPT or AI in our project. Is that I'm still on mute, right? Yeah. Okay. So what's happening is currently we are running a project in Indonesia and Thailand where we are encouraging our partners to use AI to monitor SDGs. So you do know about the Sustainable Development Goals. There's 17 goals. Against each goal, there are a number of indicators that each country reports against. For example, for SDG 6, there's an indicator on clean water. So every country has to report on how clean their water sources are and how they are improving them. So currently what's happening in countries is that all of that reporting is done manually. Manually is that a person or officer will go out into the field, for example, a lake in Chiang Rai, and go and use the manual instrument to do the measurements and then report it and send it back to the ministry, and the ministry will report it to a particular UN agency. And that the whole process takes around months, and it's a very slow process. What we have proposed, or what we're doing, is that we are using remote sensing data to do more frequent monitoring at a higher resolution, both spatial and temporal. In Indonesia, we are using satellite imagery in collaboration with BRAIN to map slums, and that slum mapping is used on how to reach out to the poor people and improve their quality of life. In Thailand, we are mapping the road accidents using satellite imagery, as well as the water quality in the Songkhla Lake. The learning from this project was that whatever AI we were using, there was no ethical element into it, and it was a black box. So it's very important that the AI that we use in the development sector, there has to be transparency. You just cannot start using AI without telling people who are impacted by that AI on how the AI works. They need to know. That's their right. That's their basic right. So this ethical element was integrated into the second phase of the project, which we are doing in Pakistan, Uzbekistan, and Sri Lanka. And the additional thing that we're doing is that we are using the sex and age disaggregated data. It's called SAD. Because the analysis that we do, we just cannot do based on the total number of people. We need to figure out how many of them were male, how many of them were female, how many were kids, how many were adults, because that changes how you develop the policy. So this is again one of the projects that I wanted to highlight where we are using AI. So now I'll just give you a very short demo on the SAT-GPT, and then I'll invite you to go and check out this link as well. So it's satgpt.net. You go here and then you can type anything. Let's get a question from the audience. If you have experienced a flood in last 10 years, can you name the city and the year? And let's try to map that one. Anyone in the audience? Just give me a name of a city and a year.
How about Nepal?
Okay, tell me about flood in Nepal, which year?
I don't know. Mr. Nishido, do you know when? Nepal? Earthquake and flooding? 2015?
So this is only for flood. Right now we're
only
only
flood.
mapping floods. Okay,
Jakarta.
Jakarta. Which year, please? 2020. Okay, so this was a random query coming in from the audience. So what's happening right now is that we're sending this query to ChatGPT, and then ChatGPT picks it up, gives us the data that there was a flood from January 1st to January 10th in 2020, and it's asking us which part of the map do you want to analyze. So let's say this part, right? We click this one, and then it gives us, okay, this is where the flood was. So you use, okay, when you're testing, you can select any area that you like. For example, let's say this one, right? Or which area do you want to analyze? We can go here. This. Okay, so I need to move up, down, left, right, left. Okay, this one? Okay, let's go here. And then let's analyze this part. So you see it was, the red part is the flood. The other thing that we have done, and that might be interesting for you, is that we have done integrated the 3D data as well as the 3D view as well as the building data in here. So once you enable the 3D view, you can view the buildings, the building footprint as well, and you can actually see the buildings that were impacted by that flood. So all of this is public domain data with additional socioeconomic data integrated into it. This is the first phase of the application, and we are looking for feedback from all the users on how to improve it. We do realize that there will be floods which it cannot map, and then we need to improve our coding part on how to improve these floods. So with that, I'll end my presentations, but I do look forward to getting feedback from you on how to improve this application. And if you want to use this in your daily work or reporting purposes, just let me know. I can share all the code of this application with you, and you can customize it as you like. Thank you so much.
Yeah, thank you very much. Maybe we have so many questions, but we must move next presenters. And final, after the 4 presenters, and so I will try to have a presentation, Q&A sessions. And so next presenter is Dr. Sumi Hon, and from UNSCAP, and so she will join online. Oh, thank you. Hello, Sumi.
Hello. Right, let me just share my screen. This one. Can you let me know if my screen is visible?
Yeah, we already watch your slide.
Okay, perfect. All right, I'll just get started. Thank you, everyone, for the opportunity to present on behalf of UNSCAP IDD Disaster Risk Reduction Section. So Hamid and I are in the same division, but within our division, there are 3 sections, one of which is Disaster Risk Reduction Section. So my name is Sumi Hong, and it's my pleasure to be able to join online and make presentation on some of the key features of the updated ESCAP's Asia Pacific Risk and Resilience Portal 2.0. Okay, so I would like to first start with the methodology of impact-based forecasting, which is used throughout the portal and in many of our works, including in our flagship report, Asia Pacific Disaster Report. So impact-based forecasting, it works by combining the hazard layer, which can be climate model, cyclone trajectory, seasonal forecast, or rainfall, temperature, etc., and by overlaying it with exposure layer, which can be various types of socioeconomic data, such as gridded population data, agricultural production, volume, health facilities, energy infrastructure, etc. And by overlaying the two, it's possible to calculate the likely exposure, such as the number of people exposed, agricultural production volume likely to be affected, and etc., etc. So impact-based forecasting, in short, it allows us to quantify the risk, identify risk hotspots, which then empowers the policymakers to, ahead of the likely extreme event to come, make preemptive measures to be prepared, to build resilience, and to reduce damage. And this is also an important component of Pillar 2, on observations and forecasting of the early warning system, to which I will come back to later in the presentation. So the Risk and Resilience Portal uses data from various sources. Most notably for climate data, it uses the latest CMIP6, SSB2, SSB3, and baseline for drought, floods, heat waves, and storms. And for exposure data, it draws from various sources, such as from WorldPop for the gridded population data, Human Development Index from UNDP, power plant capacity data from ESCAP Energy Portal, and etc. And the motivation behind the Risk and Resilience Portal was to really translate the risk from climate change from global level to a regional level, to make the visualization and what we can do with this knowledge more customizable for this region. So on the Risk and Resilience Portal, you will find country risk profiles of all 56 members of ESCAP, which includes a one-page view of the country's risk from the basic indicators of the country, such as the population, the GDP, to historical data statistics, to quantification of average annual loss under different climate change scenarios, climate adaptation priorities based on the risk profiles, and the annual adaptation cost. And as the name 2.0 indicates, the risk and resilience portal actually has been updated last year. And one of the newest features was the recalculation of the exposure risk using the CMIP6 data. Previously, the portal was using the RCP models of AR5. And multi-hazard risk was a recalculation by combining the risks of flood, drought, heat waves, and cyclone. And in the portal, it's possible to select different hazard types, such as multi-hazard, drought, flood, cyclone, and see the visualization of which areas of the region are prone to what type of risks and how the risk hotspots change with different scenarios of the baseline 1.5 and 2-degree warming. So I'll go through some examples. So this is an example of the Pacific. So once a specific hazard of interest is selected, it's possible to drill down to the region and region of interest. In this case, by overlaying it with exposure layers such as vulnerability population indicated by the low to medium HDI, we could gain an understanding of countries' respective exposure, as you can see on the bar graph on the right side. And by comparing between different scenarios, it's possible to see where the risk hotspots are emerging, shifting, and the likely impact on communities on a subnational level. Zooming into the Southeast Asian region, and by overlaying drought scenario with agricultural production data, it's possible to see how much of the sub-region's agricultural production value is likely exposed to risks from drought in the future. Especially in the case of Myanmar, Thailand, and Cambodia, the likely exposure of agriculture by value is quite significant at over 40%. And for the South Asian Association for Regional Cooperation, or SARC for short, this region is expected to experience significant challenges under the 2-degree warming scenarios for both flood and heat waves. And in this case, we made an overlay with the power plants to help inform on future plans on infrastructure investments to ensure that the new infrastructure plans are resilient to multi-hazards, especially in this case, to flood and heat waves. So in short, the portal is very easy to use and is customizable. Users can zoom into sub-regions, countries of interest, choose and compare different climate scenarios and natural hazard types, overlay with various socioeconomic exposure indicators to understand, visualize, and identify risk hotspots, as well as the likely policy interventions needed, such as improving the early warning system. And the portal is continuing to evolve and develop based on the needs and requirements of the members. In the case of the Maldives, our team has worked with the Asia Pacific Climate Change Adaptation Information Platform, or APPLAT for short, of Japan, to obtain and use a downscaled climate projection data of 5 by 5 kilometers for a more granular subnational analysis of risk hotspots, which is in particular more relevant for small island nations such as the Maldives. And you can see very clearly the difference between the left and the right maps, where the likely impact of flooding on the island and atoll levels in the Maldives really starts to appear, with visible differences in the north, central, and southern part of the countries for different scenarios. And in the Maldives projects, there was also a more in-depth analysis which goes beyond flood, drought, and storms, and also included the risk of rising sea levels also particularly important to the country. And this analysis is supporting on island level planning, which also included analysis of displacement risk, urban area exposure to sea level rise, and urban areas with low elevation, which might be subject to rising sea levels of above 1 meter. And the data and the knowledge generated from this project will support sectoral planning, especially for land planning, fisheries. Okay. So, for example, from this project, we have learned that about 22% of energy capacity in the country are located at 0 to 1 meter elevation and are under the risk of 1 meter increase in sea level under the climate change scenario by 2016. And similar project is being planned for other countries. Starting off from Bhutan, we also have another project ongoing in Central Asia. And all the current and future analysis of our section will be updated and shared on the Risk and Resilience portal. I realize I'm a little bit short on time, so I'll be skipping through some slides, but this was just to illustrate that the recent floods in the Maldives, it largely coincided with the areas identified to suffer from rising sea level rise in our Risk and Resilience portal. Just skip through these. And lastly, I wanted to connect the offer and the aim of ESCAP's Risk and Resilience portal to the global initiative of early warning for all, which was announced by the Secretary General in 2022 to ensure that everyone on the earth will be covered by early warning system within 5 years. So strengthening the early warning system is often cited as one of the most effective ways to reduce mortality from natural disasters. And ESCAP, through the Risk and Resilience portal, aims to contribute to Pillar 1 and Pillar 2 of this system. Pillar 1 refers to building disaster risk knowledge, and Pillar 2 is on observations and forecasting. Lastly, establishing strong and effective early warning system necessitates regional and sub-regional partnership, as natural hazards know no national boundaries and are often transboundary in nature. And ESCAP, through its contribution to the early warning for all initiative, through Pillar 1 on building disaster risk knowledge, through sharing information of disaster riskscape, through our Risk and Resilience portal, and through contribution on Pillar 2 on observations and forecasting, through contributions in impact-based forecasting, we hope to make contributions in achieving early warning for all in Asia and the Pacific region. So that is it. And this is a QR code leading to the ESCAP's Risk and Resilience portal. And recently we have been working on a web version of the tool, but I would say it's much more user-friendly on the computer. So please feel free to have a look. And if you have any questions, I will be happy to address them. Thank you.
So thank you very much, Sumin. And our third presenter is Dr. Yin Yora from University of Indonesia.
Thank you very much. Yeah. Hi everyone. I'm Lin Yola. I'm from Universitas Indonesia, and we actually work on GNSS technology research and development, more or less on using the GNSS as one of the tools that we do in our research, as well as collaborations and projects with the partners, including industry and local governments. And today I'm going to present about one of the applications or issues that we do research in our center, and more or less from the perspective of the user's point of view. The title is actually Integrated Water Transportation Navigations and Early Warning System in Indonesian Archipelago Area. As you can see, Indonesia consists of most of the area are water area or ocean area, and we have more than 3,000 islands, the big one and the small ones, including those unknown ones not appear in the maps. And for this area, we have three major international sea tolls. One is here, one is here, and one is here, dividing Indonesia into three categories. That's why integrating the water transportation system is actually very important in Indonesia. And by seeing the geographic characters of the Indonesia, we see different types of the settlements in Indonesia, including in the city, lake area, coastal area, and some of our communities live on the water. Not only live in the house, but also on the boats on the water. And as you can see here, the area marked in orange and green ones are the communities live on the water. That's why we do concern about them, because they don't only live, but they also walk on the water, like fishermen and etc. And of course, part of them are tourism area, and this is one of the biggest investment in our country. And this is example in Pulau Sedano and Natuna, around Sumatra Islands. As you can see, they are living on the water, and most of them are fishermen, but some of them not, but they still do the activities on the water. And another issue that we face in this coastal area is some parts of the coastal cities become affected by the sea level rise. And as you can see, the water zone here is become, in the future, it's become gone. So we also concerned about this, especially on the disaster, because we need to sometimes relocate them, but sometimes we need to modify the types of settlement in this area. And let me take one of the example that we do one research project in Indonesia, in Sulawesi Island. This is Likupang. This is one of our most targeted tourism, international tourism area in Indonesia, and they have very beautiful land area as well as coastal area and ocean area. But part of them are fishermen villages, and this is where our concerns on, because the safety of the fishermen with those small boats are really the concern, because in some disaster time, like the storm or rainy seasons, some of them just gone in the middle of the oceans without the family or the local authority knowing where they are. So yeah, this is part of the coastal fishermen settlements that we observe. And some of the issues in this area are also they have the tidal and flood disaster, and that's why our concern, we surveyed the area by using the boat and use the technology of the GNSS by using Madoka PPP receiver. And we use different types of boats, including with the one with the machine, the one without the machine, with different size of the boats. And we put it on top of the boat, and this is another type of the small boats that we also use, like what the fishermen use in this area. And we did the survey from the city center, from the land area, going to the beach area or the coastal area, and we also did some survey around the ocean and going to the islands or the remote area. And this is the preliminary survey or study that we did. The quality of the data was okay and feasible for us to implement some of the proposal that we do. And this is the sessions that we do have with the major of the local authority as well as the head of the department in that area, to know better what's the issues they have and the feasibilities of the proposal that we try to convey to them, that the integrated water transportation system concept and the early warning system for the fishermen are feasible, and what do they think about that? So this is the sessions that we have with the local authority or decision maker, which maybe in the future they would be the one for the doing the monitoring of the database. So this is the concept that we propose to the local government, that we would have the super apps to have the database of water transportation monitoring, where the boats are, including the fishermen's tourist boats and commercial boats, and we will have the local monitoring sessions station, and as well as of course, in this case we use QZSS and the Sony's presence, and it will go to the Android notifications to all of the users. So for this concept, we offer the local government that it would be integrated from the airport to the land transportations and the sea transportations, as well as the local monitoring station also could have the warning system for the fishermen boats in the ocean area. Yeah, so those are the details, but the technical ones we will have in different presentations. And this is our concern actually. It's feasible. There are a lot of issues out there, including those remote area, and we need to develop more technology for the low-cost technology, because those small boats, they don't have that budget, but there are a lot of them in the sea, and we need to be concerned about them. And the users are the local authority that we would work with. And of course, we need the collaborations and the society impacts of this technology. So I think that's it from me. I know this is the proposal stage, but we are in the process of still communicating with the local government and implementing it in the future. Thank you very much.
So thank you very much, Lim. And final presenter is Mr. Iso and Ms. Westering from NTT Data.
Thank you, Kotake-san. Good afternoon, everyone. My name is Naoki Iso from NTT Data Japan Corporation. And NTT Data Corporation is a system integrator. I'm an executive manager of social innovation division, and responsible for the location-based business, supported safety and smart living and mobility. And now, today, we would like to introduce our project called Red Rescue. Red Rescue considers the use of navigation satellite signals for disaster mitigation. We are working on this project together with Mr. Kotake. And in Japan, earthquakes occurs very frequently. Unfortunately, this month, a large earthquake and tsunami occurred in Noto area, middle of Japan. I believe that emergency warning service signals of QGSS would be useful in disasters such as tsunami and forest fires, and not only in Japan, but also in Asia, Oceania region. Now, regarding with this topic in detail, I will have Ms. Bestrin speak.
Thank you, Iso-san. Is this screen, my screen projected, or are you presenting now? I'm sharing my screen, but it doesn't work, I think. Is it working now?
Yes.
Okay. Yes, I'm Hitomi Westering from NTT Data, and today I'm going to talk about the Red Rescue project. But first, I want to talk about the QGSS. So what is QGSS? QGSS is a Japanese satellite positioning system, and the figure to the left shows the QGSS orbit, and to the right shows the service area of the DC report. I will talk about this DC report after this slide. But first, before that, I will talk about a little bit about signals from QGSS. QGSS provides not only positioning service, but also DC report service. This L1S signal has two functions, and one of them is for the DC report. So, what is DC report? That is a service that disseminates disaster management information from disaster management organizations. And it can broadcast the messages every 4 seconds. And the figure to the left shows the message format that contains all the disaster warning information, and it's called MT44 format, and it contains EWSS format that will be common message format with the EU satellite system Galileo, and that picture shows this red, red dots. I mark with red dot. We have also extended the area where you can, where disaster management organization can put the customized information, and we have it available now. So once that organization start using this warning system, they can put any information they want, but there is a limited amount, so it needs to be a little information. And I will get back to this MT44 and EWSS format later slide. So next I will talk about the EWSS. So EWSS is short for Emergency Warning Satellite Service that is used as a satellite infrastructure for emergency use. This Red Rescue 3, this project, we are currently applying this technique to an EWSS in some of the countries in the Asia and the Oceania region. And what we are doing there is, what we are doing in this project is that we are researching about the disaster risk management protocol, as well as how they are acting when disaster happened in many countries inside our service area that shows on the first page. And from that research, we have decided that several countries to conduct a demonstration. And that is currently we are doing now. Before this EWSS service will be operational in 2025 April for outside of Japan. And 2025. Yes. And what is advantage for this EWSS service? Using this Mitsubishi satellite enables this disaster management organization to convey disaster-related information to people promptly, even when they are limited on no internet or cellular communication area. For example, Mr. Iso talked about earthquake. When earthquake occurred in Japan, and then tsunami comes, but between that time, maybe earthquake can destroy those infrastructure. You cannot communicate using main communication method like a mobile network. But if you can use the network from satellite, you can at least receive the warning message, and maybe you can act the evacuation. So that is the concept or advantage on this QGSS service. So I will talk about more detail about the MT44 and message format and the common EWS format. Oh. So first I will talk about common EWS format. Common EWSS was created in collaboration with the EU, as I mentioned before. And we aim to that this format will be a standard format that will be widely used in the whole world. And this picture shows, maybe it's hard to see, but I will talk about what kind of information contains this common EWSS format. First, for example, message type, which is if it's an alert signal or like updating message that was already broadcasted, and also country name, provider code, that is that up to 32 organizations can register to become a sender for this message for each country. So we have a provider identifier on this information. And also hazard type and its categories and severity, how large the disaster is, and also hazard onset when this is issued. Also guidance library, which is promote that those users that receive the information will evacuate immediately. So it has a guidance. It contains guidance of the evacuation, and also we have target area information. Maybe most common format have how do I say, position, like point or like polygon, which prefecture is need to be evacuated or like got the warning. But we have defined with ellipse shape, so you can, how do I say, you can issue the warning not only the specific region or prefecture, but also the region around that prefecture. And yeah, there are more information, but maybe we are running on time. So if you are interested in, please ask me later. And we have created, developed admin for QGIS and ArcGIS to create this warning message, because when we had the interview to those organizations in each country, they use this GIS tools to, for example, analyze the risk of the, for example, flood situation. So when you decide the target area or create a target area, it's nice to have those add-in on those already used software. And next slide shows about the MT44 system. We are not the one who developed this system, but we supported to decide or determine the interface between the organizations overseas and the Japanese Satellite Control Center. So, yeah, what contains here? So the feature of this system is that the countries or like organizations outside of Japan can send their own warning message through the Japanese satellite QGSS to their citizens. It doesn't require any system using fee, but you just need to pay for the internet fee to transfer that message to the Japanese control center.
So Hitomi-san, 1 minute, please.
Oh, okay, sorry. So, yes. Then lastly, I will talk about the use case in Japan and outside of Japan. This picture shows the use case in Japan. that we, entity data, have a solution or system that is called the disaster mitigation communication system. And this system has a loudspeaker for many prefecture. And the good thing or feature for this system is that we mainly convey the information using mobile network, but we also use the Michibiki satellite network as a backup method, since we think that it's important to have a redundant system. And the next slide shows that the smartwatch prototype that we have developed, it's just a picture, but we developed this since many countries want to have a device that you can carry by yourself. So they wanted the smartphone solution, and smartphone has a potential that you can receive this information, but they don't send that information to application layer. So that's why we have developed this smartwatch, so you can receive it and then transfer it to the smartphones. That's all that we wanted to talk about.
So thank you very much. So we have only about less than 10 minutes, and so if you have any question or comment, it's very welcome. So do you have any questions? Okay, I have. Oh yes, please, Dr. Sauvé from JAXA. Maybe you can come here. The microphone here. Okay, please.
Okay, thank you very much. And I thought that this is a GNSS session, and maybe it's very valuable to using the GNSS with Earth observation data. Therefore, I wonder what is way forward to this discussion. Maybe one of the good ideas is because we have the APR surf session with the GNSS, so it might be good. But before that, I would like to hear about how to integrate the use of the EO and GNSS. Thank you very much.
Yeah, okay, thank you very much. And he's the coordinator of Space Application Working Group of APR SAF. And so, yeah, his advice is that we can continue the discussion about how to merge the Earth observation and the GNSS for the target disasters. Okay, would you change my slide? Yes. Okay, another questions and a comment? I have a question and a comment to Hamid Mehud and Sumihon. And so my question is related to the Dr. Sauvé. And yes, so currently the GNSS data, for example, the human location from smartphone is very important. And do you have any idea and plan to use this kind of the location data of the human and also, for example, the public transportation to your system? So this is my questions. Because you focus on the remote sensing data right now.
Thank you so much. I think it's very critical that we use the GNSS data because whatever application we design or develop, there has to be validation. And validation requires ground data. And ground data comes from, majority of the ground data for remote sensing data validation comes from GNSS. I'll give you an example. In Laos and Cambodia, we are helping the ministries with crop monitoring using remote sensing data. But for actual validation, we have to go out in the field and get the location data as well as the crop condition. And that, if we don't have GNSS, we cannot validate the satellite data. Even for floods, if we don't have the surveyed flood extents, we cannot validate the extents mapped by the satellite data. So just to put it in a single line, nobody would trust the output from satellite data if we don't have the GNSS data to validate it. So it's very important that we have the GNSS data.
Okay, and so are you planning to use this data for your system?
We are already doing it. So when we develop the SAT-GPT at the back end, that the data is being used, it is validated for Thailand, Pakistan, and a couple of countries in Pacific. So we did carry out the validation exercise.
Okay,
Yeah.
thank you very much. And do you have any comment from Sumi online?
Yes, so we will also be using GNSS data. We haven't started using this as of yet, but as our portal develops further to include more, I guess, more actual, like current information, because right now we have been using more historical data sets that we have been collecting from other entities such as WorldPop, which is gridded world population data. But as we move graduate from that to using more current data, then we will start leveraging off on GNSS data. So that is definitely in the plan, and all of this will be updated into risk and resilience portal.
Okay, yeah, thank you very much for your comment. And one questions? Yeah, you can come. So microphone, please.
Oh, thank you very much for your presentation. I want to ask about the SAT-GTP. I want to ask about the target. What is the persona for to use this SAT-GTP? Because I think the SAT is very useful for citizen. For example, like the target cannot use the GNSS, but if the persona uses SAT-GTP, it's very useful, I think. So the SAT-GTP useful for the citizen and the government cannot use the GNSS. But actually, I cannot understand your target of the presentation. So if you have target, I want to know about it. Thank you.
Thank you so much. So what's happening is that when we go to different countries in Asian Pacific and we talk to the ministries and we build their capacity to analyze remote sensing data, when we are talking to the actual technical people, the bottleneck is that they don't know how to program or how to code. They need assistance. One option is that we send them to universities and then they take 2-3 years to learn the skill and then come back to the ministry and start programming. The other option is that they have tool like SAT-GPT that can generate the initial code for them and then they can modify it. So that's the main audience, people who are responsible for generating disaster risk related information but don't have the skills to program or code.
Okay, thank you. And any other questions? Maybe one or two questions? Yeah, thank you very much. Yeah, microphone, please.
Thank you. And I just have a question or some asking some views from the presenters regarding the application for the GNSS data for the disaster management. Is there any particular initiative for example, for providing the global system to provide the data at any level to any country which is prone or vulnerable to disaster? For example, in the space community, we know we got a lot of initiatives such as Sentinel Asia, UN Spirit, and so forth, so that we can get a lot of data once we have the disaster in any place in the world. So is there any plan such mechanisms under the GNSS data policy or data protocol for the disaster management at the global level? I don't know, maybe from the speakers could have some views on this.
Okay. Maybe, I want to ask from global level from UNSCAP, and also Professor Shibazaki has experiences for location data. No, but do you have any comment how to use the location data for the sharing the global community for the disaster management?
I think this is something that's still evolving. From what I know is that currently there's no framework which governs it. There has to be discussion around it, considering the number of satellites or how GNSS is evolving. But I can check for you if there is any framework that is under the UN charters. I can definitely share with you.
Yeah, thank you very much. I think location data is much more sensitive for the privacy and the security, and so I think this is a discussion point to how to use the GNSS data for the public. Okay, so any other comments? No? Just one. Okay, final questions and comments.
Oh, thank you very much for your great presentation. I'm Akira from the Keio University. I think we heard a lot of technology skill sets, but the thing is, I want to ask someone in your view, that's what is the most challenges that you think of like, to apply your technology? Because maybe some of the literacy, education, or like the, how to say, the conceptualization, regulation. So there are so many things that we can apply to technology. So I want to ask you, like, what is the like the gap or things, issue to overcome to apply your technology?
Okay.
I'll
yes.
have a go. So
Yeah.
this is something I face daily in my work. So the biggest bottleneck is the uptake of technology. We have so many good solutions, but actually to convince a minister or somebody who's in decision-making power to actually adopt that technology and start making decisions, that takes years. It should be taking month or 2 months, but no. Even if you have a very good decision support system for drought, for floods, it's very difficult to convince them that please adopt this. This is going to save lives. This is going to save money. And this is not only in Asian Pacific. Even if you go into global north, adoption of technology for policy formulation, that's the biggest bottleneck. Yeah.
Okay. Do you have any additional, Dr. Lim? Maybe. Sorry.
Yeah, very much agree. I think convincing the users, especially on the decision makers like ministries and local authorities, is actually the challenge, because sometimes the head or the chair of that area agrees and supports, but those technical staff, they're still far behind. So like what I presented just now, we do have FGD sessions to explain what is this and what's the implications. And especially in Indonesia, sometimes we also face the challenge of infrastructures, like no network at all in that area. And to make a connected system is actually a challenge. But I think that is very much contextual, not in all of the area, but a specific area. Thank you.
I do agree with that too. Yeah. Okay, yeah, thank you very much. I thought about it, sees and needs like mutual understanding or like empathy. I think that is important. So that was the reason that I asked your question. But thank you very much.
Okay, thank you very much for your questions. And so unfortunately, I must conclude these discussions. And so, yeah, we can continue this discussion how to use the GNSS for the disaster management. So thank you very much for the audience, and thank you very much presenters. And after this session, GNSS difference session will start managed by Ashwin Choi from RMIT. So we will start just after this presentation. Okay, so thank you very much again. So thank you very much for the presenters, include 3 from online. Yes, thank you very much.
Thank you.